Hello students, welcome back. In this video, we're going to add some final finishing touches to our game Polarity. These touches are not really going to affect gameplay at all. That's pretty solid. I mean, our game is in a fully playable and pretty fun state. These changes are going to be all about visual polish that we add. Our game will look better, and when it looks better, it's just going to be more fun to play. And so a lot of times when I make these game polish videos, I try to implement, like 1, 2, or 3 systems. But here, we're going to add quite a few different changes to visually enhance our game. A lot of small changes that collectively will add up to making our game feel fully finished. So let's head to the computer screen and we'll dive right into lesson number 8, our game polish lesson. So I have that lesson open here in vscode.dev. Why don't we minimize this and open our file directly? So we'll go to the Polarity folder, lesson number 8, and we're going to open up our starter file. And right now, our game is broken. Nothing happens. Oh, geez, this is no good. Let's see. I wonder what's wrong. Well, I think this just means we've got some work to do in our missions. So what I'm going to do is I am going to actually pull up a finished version of this game. I'm going to show you what some of these visual systems are going to be. So first, right here in the HUD, I'm going to notice that I no longer have phase charges listed out as 0 to 3. I have them drawn out as neat little squares that will fill in as we pick up a phase charge. Also, let's watch what happens. As I transition my colors, they now smoothly fade. All right, so there I picked up one phase charge. Those colors don't just snap, they fade in transition from one color to the next. So that looks kind of cool. Also, we can see I have a nice highlighted line for my target. So I know I got to go to the ceiling. I know I got to go to the floor. I know I got to go to the ceiling. If I pick up all 3 of my phase charges, let's see if I can do it. Nope, I didn't get it there. We're moving faster. It's going to be harder. Let's see. Ooh, no. I got it. Ooh, well, you saw that when I hit a spike, I get a nice hit freeze. So that's going to be a nice thing. When we hit a spike, we're going to get a nice hit freeze. And let's just restart our game. Let's go slow. I'll show you what we're going to get when we pick up all 3 phases. When we pick up all 3 phases and we get that maximum phase capacity, we know our stability is frozen. We are going to draw a special effect around the player. So let me see if we can show that, and then we'll dive into the code and try to figure out why our game is starting in a broken state. All right, we got 2 out of 3 phase charges. I just need 1 more. Oh, that one spawned right inside of a mountain. That was unfair. That one I wouldn't be able to get. There we, oh, come on now. That was just unfair. Let's just see. Can I get 1 more? All right, there it is. So when I'm at full phase charges, I get this nice animating shield around me. So we got quite a bit of visual polish that we're going to add. And for some reason, we are just at a blank screen right now. So let's head over to mission number 8 and lesson number 8, and let's get into mission number 1. We're going to adjust the polish system constants. So we've got a polish system here. Let's go down and see in our student edit zone. What are we working at? Well, we have a color lerp speed and a hit freeze seconds. So color lerp speed, we are going to be transitioning from one color to another, and we want to gradually change those values. Much like when we wanted to gradually change our difficulty values, we used linear interpolation, or lerp, with our ramp. We will do the exact same thing to lerp between 2 colors so that we can gradually change from one color to the next. And the time I want that transition to happen is not 8 seconds. I'm going to do it in 3.5 seconds. That should give me enough time to go from the bottom all the way up to the top. And then our hit freeze, when we hit a spike, we're going to pause the game. It's going to give us like this stop effect. 3 seconds is way, way too long. We want it to be quite small. So I'm going to do 0.25, a quarter of a second. Just noticeable enough for us to process the fact that a spike was just destroyed, the game freezes, and then it kicks back in. It's going to act like a little hiccup in our game, which will work really, really good here. Let's see, do we have any new colors? No new colors for this lesson. And what about new gameplay variables? Any new gameplay variables? All right, we've got a hit freeze timer seconds, which is set to 0. So we'll count that timer down. And then we have polarity color current and polarity color target, and they are both set to null. And so it says here, we have a nice little comment. It says for lerp, we have to have color objects, not hex values. So we're going to try to do some linear interpolation with colors. We got to make sure we use something called color objects and not hexadecimal values. So we're going to work on that in one of our upcoming missions. So let's go to mission number 2 now. Mission 2 asks us to reset our polish constant variables. So let's go here in our reset game to defaults. So when we reset our game, we want to set those 3 variables that we were just looking at. So our hit, freeze, timer, seconds. If there was any time left on that timer, we're going to set it to 0. So it wipes that out. And then let's set our polarity color current equal to a color object. So we're going to call the color function, and we're going to pass in neon color down. Because when we start the game, well, you can't see it, but you know we start down here. And then let's also set our target color. We'll do polarity color target is equal to color. We'll set it to neon down color as well. So we'll set them both to neon down color. All right, and so now if we refresh the game, there we are, we're back in business. See, our issue was our colors were not being defined. So now they are defined. So now we have them, they're not null anymore, so our game is back in loaded. And so we're using these color objects now, these color functions, to set these polarity color current and polarity color target, because we're going to lerp from one color to the next. Eventually, we'll get to that. But mission 2 is in the books. Let's head to mission number 3. Mission number 3 is going to be, looks like 3 and 4 are together, and they are right here in our draw player function. So mission 3 and mission 4 look like they are all about our phase pulsing animation and our phase pulse draw. So mission 3, to begin here, says we want to draw the phase charge pulse effect. It says render an outer glow when fully charged. All right, so we've already got a paint in our paint bucket. It's our current polarity color. So that's kind of cool, right? So if we think about it, we are red, but we're going to draw a glow that is either purple or blue, depending on the current polarity color. So that is going to be nice. So we just got to draw an outline. So I'm going to do rect. And so a rectangle takes, 3 pieces of information. It takes an x coordinate and a y coordinate of the top left corner. So let's just do player.x, and what do we have here? We also have, the player's y value, right? Because the y value, the top left corner, is going to be dependent upon where they are attached. So let's use player y here. And then I need a width and a height. So let's do player size and player size. Player size and player size. And then let's round it. We'll round our edges by 32. I think this is gonna work terribly, but let's test it out. Let's see what happens. So here we are drawing a rectangle, and essentially this is bad because we're gonna draw that rectangle, I believe, we're going to draw the player's rectangle almost right above it, right? Player X, player Y, player size, player size. Yeah, if you look, we draw this rectangle, and then we draw another rectangle right above it. We'll never fully see this. So we actually got to change this. Let's make this, the width of this, larger. So let's take player size, and we'll add 32 to it. And we'll add 32 to the width and the height. So now it's going to be bigger than the player's body. Otherwise, this body color would just sit right on top of our other rectangle. And while we're at it, why don't we take the X position, which is the left corner, and let's shift it a little bit over here for our glow. So our glow, here's our player's X coordinate. We're going to shift it maybe over here. Let's shift it by like 16 pixels to the left. So for our rect, it's going to be player X minus 16. And let's do something similar for our Y value. We'll do our Y value minus 16 as well. All right, so now let's just see what happens. We should see a glow. I just got to get 3 pulses, which I know I'm pretty bad at that. So there's 1. There, I couldn't get that one. All right, so I got 1. There's 2. Oh, but I used that sugar. All right, there's 2. I just need 1 more. I can do this. 3. Hey, I got my aura. Look at that. I got my shield. That's pretty good. Now, what we want to do is we want to have that thing be pulsing. Right now, it's not pulsing at all. So that's going to bring us to mission number 4. So mission number 4 says there's this variable we've got here called pulse. And right now, it is set to +6. All right, well, why don't we take this and add this pulse variable to all of our positioning of our rectangle. So that left-hand corner, which is we're taking the player's X position, we subtracted 16. I'm now going to subtract a little bit more from it. I'm going to subtract the pulse variable. Same in the Y direction. I'm going to subtract 16 from the player's Y, and then we'll subtract a little bit more, our pulse variable. And then the width of the rectangle and the height of the rectangle, let's also add it. So we added 32 to make it a little bit bigger. Let's add a little bit more. Let's add our pulse variable, and let's add our pulse, I don't know, let's multiply it by 2 so it's a bigger effect here for the width, and we'll add our pulse variable times 2, so it's a bigger effect for our height. So now we've just basically made that shield bigger. Let's just verify this. And you know what? Let's go up here. I'm going to jump up to my constants in my student edit zone. Where is my phase constants? Max phase charges. Let's change it to 1 for right now for testing purposes. So I'm going to get this shield at 1 phase charge now. So now my max phase charges is 1. I just got to pick up 1 and we'll be able to see it. This should look bigger now for us. Let's see. Oh, and it does. It does look bigger. So there it is. But I don't want it to stay bigger. This is like the maximum value I want it. I want it to grow and shrink and grow and shrink and grow and shrink. I want it to actually pulse. And so what we need to do is not have this variable be equal to 6. Because look, if it's equal to 6, it's pretty big. But watch what happens if I only set it to 1. So now if I set it to 1 and I pick up, let's see, a pulse. Where are my pulses? Here we go. It's a little bit smaller. So that looks pretty good. And what if it's to like a negative value? What if it's like -5? So if it's -5, well then we probably shouldn't see it at all, I think. Well, maybe we will see it. Oh, come on now. We're not going to, it's going to be really small. It's going to be even smaller. So let's check it. Yeah, see, there you go. So we want that to dynamically change. We want it to grow and shrink and grow and shrink. So we got to target this value. So we need some function that's going to grow and shrink, grow and shrink. And the thing that's going to grow and shrink for us is a sine function. So we're going to call the sine function. And in here, we're going to have 2 really important pieces of information. Just to quickly describe it, I'm going to go to my whiteboard here, and I'm going to map out what a sine wave actually is. So we can think of a wave as being something that has a high value, we'll maybe say +1, and a low value, -1. And in some interval, that wave's value goes up and down, and then it increases in the negative direction and goes back to 0, and it goes up and down. Perfect. Now there's a couple of properties here for the wave. Basically, how high up it goes or how far down it goes is known as the amplitude, and different waves have different amplitudes. So I can make a wave. If I took this wave and say maybe I multiplied that wave by 2, now instead of just going up to +1 and -1, it would go up to +2 and -2. So it's going to have a higher amplitude. All right, so it's going to go further out. So that's one wave property, amplitude. Another wave property is called frequency. And frequency is essentially how many waves you can fit in a unit of space. I drew that one poorly. Let's try that again. So right here, I fit 1 wave in that unit of space. Here is a wave with double the frequency. I can fit 2 waves in this space. So I'm going to go up and down, up and down. So frequency is like how fast the waveform is occurring. And we can say a sine function, sine x times a, where this is the frequency and this is the amplitude. Basically, how fast the wave is going to be moving, frequency, and how far the wave is going to be in terms of its strength, that is our amplitude. So we just got to plug in those values. So for our frequency, I'm going to plug in run time seconds. We're keeping track of that time, and I'm going to multiply it by 6. So if you want your wave to go faster, bloop, you just change that number. If you want to go slower, bloop, you just change that number. And then I'm going to multiply my amplitude by, let's say, 6. So that's a measure of how big the wave is going to grow. So let's test this out now. If I refresh the page and we run this, as soon as I pick up one polarity charge, that system should be in place. All right, and we have it growing and shrinking. Now, I like that. I like those numbers. Let's just mess with those numbers a bit. Let's make the amplitude much larger, 20. So now we're going to grow and shrink at a greater distance, and let's make our speed much faster. Let's make our speed 20. So now we're going to see that growing and shrinking happening quicker and quicker and quicker because the frequency got higher. So one phase charge, here we go. Whoa, maybe you like that. I don't think I like that, so I'm going to go back to using 6 and 6. But I just wanted to show you that's what those parameters do. That is the frequency and the amplitude of our waveform. Mission 3, Mission 4 in the books completed, and our pulse animation for our phase charges are done. Let's go look at mission number 5. Mission number 5 says we want to target our lane highlight. We're going to highlight our target lanes. So this is in our draw HUD function. Our draw HUD function is where we are drawing the ceiling line and the floor line. And right now they are the same thickness or the same weight. We are going to change that. So if you look here, we ask a question. We say if the refill target attach point line is equal to our ceiling line, what do we want to do? Well, it looks like we're drawing our ceiling line and we're drawing our floor line. And each time we grab a marker whose weight is 2. Well, if our target attach point is the ceiling line, I want to draw that line thicker. So here's where I draw that line. So I'm going to pick up a thicker marker. So instead of having the weight here be 2, let's make the weight 6. And then if the refill attach point target is not the ceiling, then it's going to be the floor line. So that means this else block of code will run. So now I want to pick up a thick marker before I draw my floor line. So here we'll pick up a marker whose weight is 6. And now we should get some nice visual feedback for what line we need to target. So there you can see I got to target the ceiling, and now I got to target the floor, and now I got to target the ceiling, and now I got to target the floor. And I almost don't even need to look at the HUD anymore because I have visual feedback in my game, which makes it very helpful. I can keep my eyes right on the game world and not necessarily have to be scanning up at the HUD. Awesome. Mission number 5 is complete. Let's look at mission number 6. Mission number 6 says we want to draw those little HUD phase squares. So this puts us in... Where are we? Oh, we're in draw HUD still. Okay, well that makes sense because our squares are inside draw HUD. It says draw phase charge squares in the HUD. Display filled squares based on the current charge count. Okay. Well, let's see. I feel like we got to do a lot of code here to draw all those squares because there's like we got to draw like what is it? 3 squares. We got to position them. We got to have the logic that fills in their color. And when you have a lot of code like that, it's often best to separate it into its own function. So let's scan and let's look at what we have right here. We've got something called draw phase display. Ooh. Well, let's see. We create a variable called size, called gap. We get a right X position. We create some text that says phases. And then it looks like we loop through using a for loop to our max number of phase charges. We get an X position. So we figure out where that square is supposed to be drawn. We get an invisible marker. We put the right paint color in our paint bucket, all right? And then we draw a rectangle or a square. So I think this whole function is going to draw that for us. We just need to call it. So I'm just going to call that function draw phase display. Oh, got to spell it right. And by calling that function, all of this code is going to get written for us. Now, you might not be able to write this code, but I'm confident you can understand what is happening in this code, right? We're setting some variables for positioning, we're filling out our text, and then we're looping to draw the same rectangles over and over and over again, but changing their X position, that left-hand corner of where we draw them. So now if we refresh the game, hey, why do I only got one phase charge? Oh, that's right, because I had set our constants to 1. So I got to go change that. So back up here in our student edit zone, I'm going to change max phase charges. We had it originally set to 3. And so now when we run our game, there are our 3 phase charges. Let's pick up a phase and let's see one of those things get filled. All right, so there it is, blue. I change color, it changes, so that's working. I get a second phase charge. Oh, and then I died. Well, once we fill, I'm going to pause the game and see if I can get full phase. Okay, so now I have full phase charges, and this is working out perfect, okay? And look, we're back with our oscillating, our pulsing shield. Very, very good. Okay, let's look at mission number 7 here. Mission number 7 is all about our hit freeze effect. So when we hit a spike, we want to pause our game slightly. And we have a little timer for this, right? So we have a teeny little tiny timer. Let's go look and see what happens in check player spike collisions. So I'm going to go down to that function. Check player spike collisions. All right. When a collision occurs, as long as we have a phase charge, so this is where our collision occurs. If we have a phase charge, we reduce our phase charges. We're splicing that spike out of our array spikes, and then we set our hit freeze timer seconds. So you can see right here, we're setting that timer. So now it is no longer 0. It's equal to 0.25 seconds. So what we have to do is, in mission 7, ask a question. We got to see what is the value of that hit freeze timer. And if it's greater than 0, we actually have to pause the game. So we're going to say if hit freeze timer seconds is greater than 0, we want to pause the game. So we're going to come over here and we'll run this else statement. We'll run this if statement. If it's not less than, or if it's not greater than 0, meaning like it's 0 or it's negative, then we'll run our else statement. And in our else statement, we do all of our game updates. So the only way we're going to update all of our game here is if the hit freeze timer is not greater than 0. Let's run this. Let's check this out. So right now our game updates because our hit timer is equal to 0, so that's good. And now when I hit a spike, oh, I got to have a phase first. Let me pick up a phase. All right, so there's I'm really bad at this game. Let's grab a phase. All right, so now I got a phase. So now if I hit a spike, we pause the game. Hey, that's perfect. We have our hit freeze effect, but our hit freeze effect is not ending. So that's really bad. Like we just broke the game. And that's because we set our hit freeze timer, it's less than 0, and then we're just running this. And look, we're not decreasing the timer at all. So the hit freeze timer got set to be 0.25 seconds, and now in our draw function, which runs every frame of our game, we're checking to see, is the timer greater than 0? It is right now. It's at 0.25 seconds. We're just simply subtracting 0 from it. We're never counting it down. So let's count it down by subtracting dt. Of course, this could go negative. So what we're going to do is we're going to constrain it. We'll then say hit freeze timer seconds is equal to the constrain function. And we'll pass in hit freeze timer seconds. And we'll constrain it between 0 and what's the maximum value it could have is probably hit freeze seconds. That's the what is it, the 0.25? Yep, the 0.25 seconds right there. So now we are actually decreasing it. And so once it gets to be 0 again, this will no longer be true. So our else block will run and we'll go back to updating our game in its entirety. All right, let's test it now. So now we will not have that infinite freeze effect. I just got to get a phase charge, and it seems like I am really bad at that. Ooh, but I got one here. So now if I hit, freeze the game, and then we're back at it. And so this is going to be a really cool effect, especially when we're moving extremely fast. It'll give us a chance to like grab our bearings and figure out where we are at. All right, one more mission, and I think there's just one more visual system that we want to put in place, and it involves a lerp between two particular colors. So in our update world, it looks like we are targeting mission number 8. We want to animate our polarity color transition using lerp. Smoothly blend towards the target color over time. All right, so we know a bit about linear interpolation. Linear interpolation is going to move from one value, one starting value, to an ending value based on a value between 0 and 1. So we've lerped through numbers, and we can also lerp through colors. So what we're going to do is we're going to take our color lerp speed, which is currently set to 3.5, and we're going to use this value to transition from our current color to the target color. So right now, if we look, it just says we have polarity color current equals polarity color current. So we don't want that. So instead, we're going to lerp. Now, we're lerping between colors, so we need to use the lerp color function here. And we're going to specify a starting color. So we have a current color that we have. So if you look here, my current color is cyan, and I want to lerp towards the purple. And then when it's purple, I want to lerp towards the cyan. In fact, that color is constantly going to be changing. We're going to shift from one hue closer and then closer and closer. So our starting value is going to be polarity color current. And our ending value is going to be polarity color target. And the amount that we're going to move through is our blend step. So let's see if this is going to work for us. I have a feeling it's not, but let's test it. All right, so here we are. And it looks like it's just snapping in place. All right, so it's still not working. And the reason why is the color lerp speed is 3.5. Well, that would be like pixels every frame. But we want to make sure we're doing it based off of, or that's going to be pixels per unit of time, right? Pixels per second. We got to make sure we multiply by our unit of time. Just like we've been doing here with any time-based system, with a speed, we have to multiply that speed by dt, by time. And so now we're going to get the correct value here. So let's just say, okay, if our color lerp speed is 3.5 and dt is 0.033, well, then we get 0.11. So essentially, like, that's going to be 11%. So if we start at the cyan, we're going to move 11% closer to the purple. And then the next time, we're going to start at that 11% closer to purple color, and we'll move 11% closer to purple. And then we'd be 22% closer. And then we'd do it again and again and again, every single frame here. So let's test this and see if this is going to work. And now we get that really nice faded transition effect. And I believe with that color lerping, which gives me a really cool blending of two colors, our polarity game is complete. Let's give it a full play test. So I'm picking up my phase charges. I want one more. I got all phase charges. Now I have infinite. I'm not draining my polarity at all. Or draining my stability. But the game is getting faster. It's getting, oh, I lost those phase charges. All right. My ramp is only at 55. Oh, no. Okay, I lost my phase charge. I got one phase charge left. All right, two phase charges. I get one more. I get my maximum stability. Awesome. So now stability is set. I lost it. Okay, let's see. We're moving really fast now. My ramp is at 82%. Oh, I'm down to one phase charge. Those phase charges come in handy. They really help keep us alive. And just like that, I survived 54 seconds. That's going to be my best run. So if I play it again, that best run is locked in. And I urge you, can you beat 54 seconds? I'd like to see you try. I think that's a pretty good score. Better than that score is what we did here, taking this really bad game when we started lesson 1 and working to get to where we are right now at the end of lesson 8. We have multiple systems in place that are all working together to create this infinite runner of polarity. I hope you are happy with what you've done in these lessons, and you should be really proud of yourself. I know I'm proud of you for sticking with it. So with that, I'll see you in the next video.